Have you ever studied permutation and combinations? This is math workshop. Have you ever studied it? Never? Okay. Well, let's talk about permutation and combination. First thing you do on these, you got to determine whether it's a permutation or a combination. Permutation, order matters. Order matters. Select order matters. And the way I remember it, permutation, place. You're placing something. You're arranging something. Placing. Combination, you're choosing something. Choosing something, okay? Do I have everybody's attention, or do I need to get real loud? Okay. So let's read these situations. Let's discuss what you think it is. Number 17, the winner. And first, second, and third runner-ups in a contest with 10 finalists. Would order matter in this? Yes. Who won, who came in first, second, third would? That's a permutation, okay? Number 18, selecting 2 of the 8 employees to attend the business seminar. Selecting is the same kind of word as what? Choosing. So that would be a what? Combination. 19, placing an algebra book, a geometry book, a chemistry book, an English book, and a health book on a shelf. What would that be? Permutation. You see that? Alright, now, let's talk about how we would work these problems. Alright, we said this first one's a permutation. Here's your symbol for permutation. The N, all this be on your test if you will. Seniors, yes, you will take this test before you graduate. N is your total number you got in the situation. R is how many people or how many things you want. So how many people do I have total here? 10, comma. How many people am I choose? I mean, how many people is this going to affect? 1, 2, 3, what? 4. So P parentheses 10, comma 4. Okay. Now, when I follow this formula, I will give you this formula. N is your total number, so I got 10 factorial over 10 minus 4, which is what? 6 factorial. Do y'all see that? So 10 minus 4 is 6. Now when we work this out, 10 factorial, do I have to go all the way down to 1? I could do 10 times 9 times what? 8 times 7 and stop there because the 6's will cancel out with it. So do that right now. 10 times 9 times 8 times 7. Tell me what you get. Thank you. 5,040 different ways I could have in this situation. That's a lot. That's quicker than drawing all that out, isn't it? Number 18, we said selecting, same thing as choosing. This is a combination. C, parentheses. How many do I have to choose from? 8. How many am I choosing? 2. Follow this formula. This is combination. 8 factorial over 8 minus 2 is 6 factorial times, how many do you want? R, N is your total number. R is how many you picking. Okay? Or how many you're dealing with. N is the total. R is how many you want to deal with. Alright, so I said 8 minus 6. Okay. Now, when I work this problem, how far do I have to multiply down from 8? 8 times what? Because the 6 is canceled out, don't it? So 8 times 6 is? 8 times 7 is, 8 times 7 is? 56. Divided by, what's 2 times 1? So that is what? 28. That's your answer. That's 28 possibilities. And we said number 19 was permutation because you're placing something. How many total do we have here? Total things we're dealing with. 5. How many things are we placing? 5. So in this case, both your N and R is the same thing. You have a total number of 5 and you're placing all 5. Alright, so let's talk about how we do this. So that's going to be 5 factorial over 0 factorial. Remember what 0 factorial is? What's our accepted value for 0 factorial we learned? 1. So anything divided by 1 step. So all you got to do is worry about 5 factorial. What's 5 times 4? Times 3? Times 2 is? Y'all some of the brightest kids in this school. Let's do that again. 5 times 4 is? 20 times 3 is? 60 times 2 is? 120 times 1 is? We just had a number talk. 120. Very good. 120. Number talk is where you talk about numbers, like an elementary went on. So how many different ways there is to make 8? I can see you can roar. 2 and 6. We got that up. You talk on the road. You're just innocent. You're not on. Yeah. Sure. You're just bad. I can tell you just running around pulling stuff off the shelf, wasn't you? You were shy. She's still there. Yeah. You wasn't bad. You were sweet angel. Like a little. You just smile. You just steal some Snickers at recess, did you? Who's your kindergarten teacher?
Miss Williamson. I don't know if she's still there. I don't think she's retired.
Creepy? Oh, no, she's retired. Who's your kindergarten teacher? She's sweet. You was Angel. Yeah, but who was your kindergarten teacher? He has it for here at Thompson High School probably too.
He had 86 this year.
His what year?
Kindergarten.
Probably tripped somebody, didn't he? Alright. Now, do y'all want me to show you how to do this on the calculator? You don't have to do the formula? Because I made you do all this to appreciate the formula, but now there's a calculator button. Okay, get your calculator out. So we're going to put this first one. We're going to put this in our calculator and it shoots out this answer. You don't do all that. Okay? If you go, let's say we want the permutation of 10, 4. What you do is you have 10 first, the first number in the parentheses. You got to get your parentheses right. Because if you put 4 first, it's not going to give you the right answer. Always put your total first and what you want, okay? Then, go to math. Scroll over to PRB. That means probability. Do you see number 2 and 3? Number 2 is permutation, 3 is combination, okay? So I'm going to hit 2, and then hit how many I want. Isn't that what you got in the formula? Isn't that awesome? You can do that. You don't have to work all that out, okay? Now, what was our second one? What was our combination? Combination. 8 and 2. Let's do that. Should I put 8 first or 2 first? 8. Go to math. Hit 3, 2. Is that what we got a while ago? Let's do our last one. Hit 5, math. I wanted 5. So do you have to show me all that other work? No. Are y'all good on that now? Don't forget what that's at. It's under math. A lot of stuff's in math. That math stuff. If you ever wonder what's something out, just look in the math. Oh, we could, yes. Let me play with this thing and talk about what tomorrow. Yeah, I got to figure out what's wrong. I've seen it before. It's not the end of the world. I can fix it. I just got to figure out how to do that. All right. Are we good on that? All right, let's get our homework out from yesterday. Oh, y'all are about to let me forget Trivia Tuesday. First period for Let Me Forget It, we were taking it at 8:59. They had 3 minutes at 9:02 in the bell room. Where's my Trivia Tuesday at here? Will you assist me here, Josh? Big grand cookie that day she had in my class. still, that's going to my book one day.
No.
I gotta leave this shit. Your granny cooked me. I said,
No.
dinner. You want me to go to lunch? Is she gonna strike it? Scoop this out?
I left the doctor appointment that day. For dinner. We have burgers with toasted buns.
Oh, that's right. But you told me you were going for lunch and you lied to me. See, you didn't say all that. You said Granny's cooking you lunch. And
She's
you
cooking me dinner. I never said lunch.
Yes, you did.
No, I didn't. Okay.
You should say you read the text and this text on said, I have a child leaving. Go eat lunch for Granny. She must strike for dinner. You told me lunch. I'm not mad with you. I'm just picking with you, but that is funny. You did tell me lunch.
I did go get lunch after my doctor's appointment.
Don't start yet. Don't start. Just write that name. The door's going to be closed. How's 1984 going? You know, that's the year before I was born.
That's cool.
Born in 85. It was a spectacular June
Did
day.
you read it when it came out?
Huh?
Have you ever read this?
Never read that book. I'm going to tell you, I didn't have the best English teachers in high school. I only read 2 books my entire 7th through 12th career. That's the only 2 books I was required to read. One was Romeo and Juliet. The other was Julius Caesar. Oh, I did read a third one. Great Expectation. That's it. I didn't read stuff till I got to college when.
Did you just focus on your land judging?
And also, you know how many papers I wrote in? You know how many papers? I was on land judging. I'll tell you a story one day. You know how many papers I wrote in high school?
2.
1. Senior research paper. And it only had to be 2 pages. Like I had to learn how to write when I got to college. My only B was at English 101 because I didn't know how to write. I had to teach myself. 1 paper, 9 through 12. That was it. All right. Here we go. Now I had a good math teacher and a good science teacher, but my English and history was the situation. Here we go. You need 3 minutes. Start now. You have 36 seconds remaining on this quiz. Snap and walk up. Lane, how you doing?
Alright.
You ready to go to college, aren't you? Everybody good? Gotta give you 30 more seconds to check your answers. Check your answers. Check the sign. Take the time to check your signs. I'm sorry. Not the liking. All right, Josh, collect those for me, please. All right. Now, we're done with that math workshop, so you get a whole new one tomorrow. I know you're excited. I know. Contain yourself. You hit this, yes. Like how to count to 10 trick. If she don't review that, like Josh, okay, tell them the first day of calculus. She starts teaching on that Thursday. Teaches Friday, Monday she tests. The first, yeah. She tests you over everything you're supposed to learn in PreCal. So you have Thursday, Friday, and then Monday's a test. So that's what I'm telling you right now. So you need to keep your PreCal notebook and kind of review this summer a little bit. Now, for y'all, if you want me to review you a little this summer, I could meet up here like one a day and we could do a PreCal review or something. Especially some trig. Alright. So she has one of the highest passage rates of any AP teacher in this school. 100% of her Cal BC passed the test last year. 75% of hers passed AB. So I'm going to tell you, she's tough, but she's good. So here we go. Guys, Mr. Esther's talking. That means close it. Okay. Didn't we do some of this homework together yesterday? Did we do 1, 3, and 5 together? Okay, what I want us to do right now is review number 2. Remember yesterday, our target for the day was I can find a limit using a table and graph. Okay, a limit. What is a limit in your own terms? It's a value that is what? Approaching, isn't it? It's getting close to. It's not the same thing as F of that number, is it? F of that number is this exact answer. That as X goes to something, is that what is the value that on function approaches that X value? Does that make sense? Do you see the difference between those two things? Okay, so we want to use the table feature of our calculator. So I want you to put that in your calculator and observe what's going on at -1 now. Please get your calculator out and put the function in. Okay, go to mode. If you're at the y equals and it is not y, that means it's in another form. Go down, scroll to 1, 2, 3, 4. Line and get function. Highlight it. That's it. You're welcome. We should not be still flipping pages. We should be on our homework doing number 2 right now. Get your calculator. I need you to put that, and I need you to observe the behavior of that function in that table, please. at this table at -1, it says an error has occurred. When you see an error, that means there's some type of continuity. There's a hole, there's an asymptote, there's a jump. Well, we know it's not a jump because that's not piecewise, is it? Okay, so it's either a hole or an asymptote. Okay? So what is a good value we could put as approaching right there? What would you put? -0.33. That's good. If you put -0.32, I'll count that. This is just using a table to see what it gets close to, okay? Yes, buddy.
Mine says -0.5.
Let Alyssa check that out for you right there. Alyssa, will you look at this and see what he typed in? I got a feeling he typed it in y equals. Did you put everything in parentheses? Did you put the numerator in parentheses and denominator both?
Yes.
Keep scrolling over. Well, that is quite strange, Kelsworth.
I needed to take it.
That is quite baffling.
I got all my things wrong. Or different.
I gotta take a look at your calculator later, but I've never seen calculator later. And figure out what's going on. Now go get you another calculator out of the shelf. Remember? You got that 133? All right. Does everybody understand that problem? Are we good on that one? Do we need to do another example like that, or are we good? Okay, so let's look at our homework. Let's look at our homework. I want you to check number 9 and 11 right there. And I'm going to explain all of them. I just want you to check 9 and 11 right there. You need to take that call? Sure. She call back? I really like this unit. It is my favorite units. Alright, so let's look at number 9. Why our values are where they are. It says the limit as x approaches -1 from the right. That little pause to me from the right. So I'm only concerned. So here's -1. If I'm coming from the right, it's approaching 2. Do you see that? If I'm coming from the left, it's approaching 2. That was a minus, a little negative there. So that means you got to look at it to the left. Now, when there's not a plus or minus after the numerical value, that means you got to take it upon yourself to look at both right and left. Does everybody understand that? So, but you kind of do that work right here. These numbers are both the same, aren't they? So, what's your overall limit? 2. The limit as x goes to -4. They did not have the plus or minus, so you got to look at both the left and right side. So, coming from the left, it's approaching what? 3. Coming from the right, it's approaching 4. Are those two different numbers? So your overall limit would be does not exist. Okay? The limit as x approaches, what is that, 4? Okay. If I come from my left, it's approaching what? Y value. If I come from the right, it's approaching what? So that's why it does not exist. Does that make sense? Okay. Do y'all like this better, hyperbolas and parabolas and all that? All right, number 11. All right, the limit as x goes to -2 from the left. -2. See, I'm coming from the left, is approaching -2. From the right, it's -2. This is the overall. Well, both of those worked out, so the overall is -2. You have what's called one-sided limits and overall limit. This is a one-sided limit, and that's the overall limit. Does that make sense? Because you're only looking at one side. The limit as x approaches. Now, let's make sure we understand how to read this. The limit as x does what? Approaches what? -4. Thank you, buddy. As x approaches -4. Alright, so I look at -4. Come from my left, it's approaching what value? What y value is it approaching? 2. From the right, it's approaching. Are those the same numbers? That does not exist. And then the last one is -2. Are we good on those? I want you to do number 12 right now on your paper. Do number 12. We're going to go there. At the end of the week, I'm going to do a homework check for completion. and a homework check for correctness. We're just going to start doing that every Friday. Just know you're going to get 2 homework grades. Completion, you attempt to get 100, and then choose 10 for correctness. So if you, and I think I'm going to start doing that now, so if you have a rough night where you have so much homework and you don't get to it, you better make it up the next day, but by Friday you better have it all done. If I go with that, that's what we're going to do the rest of the year, because this is me going around. I'm just going to do that every Friday. Next year I'm going to start that from the beginning. Yes, sir. Oh. Let me see what happens right now. Oh my words, you're lucky there.
Thank you.
Alright, so number 12. What is the limit as x approaches 2 from the left, Caitlin Glover? Very good. Caitlin Roberts, what's the limit as x approaches 2 from the right? Thank you. 2. Very good. Luke Glover, what's the overall limit as x approaches 2? Very good. Anthony, what's the limit as x approaches -4, buddy?
0.
Very good. And the last one, what's the limit as x approaches 5, Will?
-1.
Very good. Are there any questions on that? That's your first 2 learning targets, that you can determine the limit from a table and from a graph. Well, we're good with that. Okay, now, let's look at our learning target today. Well, how are we going to determine it today? Algebraic. I'm going to give you the function. There's no picture, there's no table, and you got to figure it out, okay? It's not bad. All right, so I want you to turn to page page 3. And we're going to work on this today and tomorrow, okay? Today and tomorrow. I want you to have a self-reflection moment right now. Think back to 9th grade when some of you are in algebra, some of you in geometry. Aren't you just amazed with the math we got to now? This is pure calculus right here. You're living. Aren't you proud of yourself? Aren't you proud?
I am.
Yeah. I mean, when you go to college, guys, you're going to be amazed. When you step in your math class, and whatever math you place in, I taught you everything that you would see in college in those first couple math courses you've seen. Now, they might teach it differently, but you've seen it, okay? You will be amazed at the students in your class that have never seen my unit circle. It was amazing. You will be amazed when some kids that have never seen a logarithm. And you're going to sit back there and say, well, at least I've seen it all. Now, like I said, it can be taught differently, but you've seen it all. So, and I'm going to tell you, we have some great kids at Thompson. There's a lot of kids that don't get to this in PreCal. But y'all are great, and we get to this kind of stuff, and I'm glad I get to teach you this stuff in PreCal. Okay, so techniques for finding limits algebraically. First one is try direct substitution. What do you think I mean by direct substitution?
Replacing something directly.
Very good, very good. All you're doing is taking the value that x is approaching and plugging in for the function. So if x is approaching 5, what's my number I'm looking at? 5. I take 5, plug it in. What's my answer, number 1? 5. That's all you do. That's the easiest strategy. Now, direct substitution does not always work, but that's easy. That one is 5. And then you say, Mr. Fish, when does direct substitution don't work? Direct substitution does not work if you plugged it into a problem and you get 0 in the denominator. You don't want 0 in the denominator because that's what? Undefined. But if you don't have that situation, you can do direct substitution. Like on number 2 here, as x approaches 0. Let's plug 0 into my denominator and see what I get. What's 0 squared? 0 minus 25 is what? Negative 20. Is it okay to have negative 25 in the denominator? So you can use direct substitution. I'm directly substituting that x value that it's approaching into here. So let's do that. So let's be 0 minus 5 squared. 0 squared minus 25. What's 0 minus 5? Negative 5 squared is? 0 squared minus 25 is? So that gives me a negative what? So my limit, as x approaches 0, is approaching the y value of negative 1. As my function, as I'm going to 0 on the x-axis, my y value is going to negative 1. That's what that means. Does that make sense? Make sense? Number 3. Let's say this one together. Let's make sure we're correct. The limit as x. I want you to say this problem. I'm just trying to get you to know the vocabulary. The limit as what? Approaches 1 of square root of 5x minus 1. Do we understand how to say that? Okay. I take 1. I plug 1 in. Am I getting a 0 in the denominator? So can I do direct substitution? What's 5 times 1? 5 minus 1 is? Square root of 4 is? That's your answer. Number 4. The limit as x approaches 5. I take 5 and I plug it in. When I plug 5 in the denominator, 5 squared is what? 25. 25 minus 25 is? Ooh, I ran into a problem now. So I can't do direct substitution here. Okay? So 25 minus 25 is what? 0. So I can't do direct substitution is always your first plan of attack. So here's your other strategies. You ready? You can factor, rationalize the denominator, or I'm supposed to say something new at you. Did you know you can rationalize a numerator? So you're either going to be rationalizing a denominator or numerator, and the third thing is find the common denominator. Those are your other strategies. If you cannot do direct substitution, you need to try to factor, rationalize either numerator or denominator, or find a common denominator. So on number 4, what do you think would be easiest for us to do here? Okay, guys. You got. I just gave you 3 techniques. Is there a square root in there? So would rationalizing be a good one? No. Are there any fractions in that problem? No. So do we need to find any common denominator? So what's your other option? Thank you. Factor. We're going to factor, okay? So let's look here. I got x minus 5 and x minus 5. Difference of squares, x plus 5 and x minus 5. Can I cancel out one of these x minus 5s? Yep, I can I? Now, once you do that, once you do one of those techniques, then you go back to direct substitution and see if it works now, okay? After you do that, then you go back to direct substitution. I plug 5 in the denominator. What's 5 plus 5? 10. I didn't get 0, did I, in the denominator? That's all I'm concerned about is 0 in the denominator. So you can directly substitute now. Now I got 5 minus 5 in the numerator, 5 plus 5, that gives me 0 over 10. What's 0? Is it okay to have 0 in the numerator? So what's your answer? 0. Okay? Look at 7. 7's the easiest one on the page. The limit x approaches 2 of 12. Is there anywhere to plug a number in? So what's your limit? 12. All right, let's go back to number 5. Huh? You like this, Mary Catherine? All right, number 5. They have a denominator, so I'm concerned with what? Negative 2. I'm going to try plugging negative 2. Let's do this together, okay? Negative 2 to the 4th would be what? 16. Negative 2 cubed is what? Negative 8. Negative 8 times 2 is what? Negative 16. So does that 16 negative 16 cancel out there? So So don't worry about that. Now, let's look at this part. 4 times negative 2 is negative 8. Negative 8 plus 8 also does what? So you got 0 in the what? So can we do direct substitution? No. Does that have any radicals in it? Rationalizes, ruled out. Do I have any adding, subtracting fractions? So the only other option I'm going to do what? Factor. Okay, factor. Here we go. So I'm going to factor, grouping. So I take an x squared out, that leaves me an x plus 2. I take a 3 out, that leaves me an x plus 2. Take an x cubed out, that leaves me an x plus 2. Take a 4 out, that leaves me an x plus 2. Now I'm going to rewrite that as x squared plus 3 and x plus 2 over x cubed plus 4 and x plus 2. What can I cancel out there? They can cancel out. I'll give you a minute to catch up. Alright, now let's go back to direct substitution, see if it works. I'm going to take that negative 2 and plug it in the denominator. Negative 2 cubed is what? Negative 8 plus 4 is? So did I get 0? So can I do direct substitution now? Yes. So now I'm going to plug that negative 2 in. Negative 2 squared is 4. 4 plus 3 is 7. Negative 2 cubed is negative 8 plus 4 is negative 4. So it's negative 7/4 is your answer. Okay, number 6. I take my negative 1. I plug it in the denominator. What's negative 1 squared? 1. 1 minus 4 is? So am I good with that? So can I do direct substitution? Yeah, because it didn't give me 0, so that gives me a negative 3 in the denominator. Now, negative 1 squared is 1. 1 plus 2, because that gives me a positive 2. Once I put that in there, that's going to be 3. 3 minus 8 is negative 5. What's negative 5 over negative 3? 5 what? Speak up. Since I can cancel these two out right there, is that removable or infinite? Removable, because didn't I remove the situation? What type of discontinuity is this an example of? I'm about to jump if you don't pay attention. What type of discontinuity is this, class? Jump. Okay, now, so here we go. We're using this information. The limit as x approaches 1. Which part of this would I plug that in? Top, middle, or bottom? It says for x is less than 2. Isn't that less than 2? So I'm going to take 1. I plug 1 in. Do I get a 0 in the denominator or anything? No. So if I plug 1 in, 1 squared is? And that negative makes it negative 1, don't it? Negative 1 plus 8 is? That's your answer. B. As x goes to 2, would I plug it in the? Would I plug it into the top or the middle? Middle. Alright, so what's 2 times 2? 4. Alright, take the 4. Where am I going to plug the 4 one in? Top, middle, bottom? 2 times 4 is? There you go. Are y'all good on those? Let's look at number 9. It is the limit as x approaches 9. If I take 9 and directly substitute that in, I get 9 minus 9 is what? 0. That won't work, will it? I can't do direct substitution here. Okay, so I have to go to my toolkit. Can I factor anything there? No, that's ruled out. Do I have any adding, subtracting fractions? Any adding, subtracting fractions? No. I'm sorry, my book is cramped. There's a radical in there, so what do I need to do? Rationalize. But this is something new because we never rationalized the numerator, have we? But that's mathematically, you can do that. So here I would rationalize the numerator. Watch how I do this. I'm going to do it on a piece of notebook paper so you can see. Alright. So, the limit as x goes to 9 of square root of x minus 3 over x minus 9. So I'm going to multiply this by what? What do you think? Square root of x what? Plus 3 over square root of x plus 3. Now I'm on 4. Square root of x times square root of x is what, guys? What happens to square roots? Cancel. Square root of x times 3 is 3 square root of x. Negative 3 times square root of x is negative 3 square root of x. Negative 3 times 3 is negative 9. Over x times square root of x is x square root of x. X times 3 is 3x. Negative 9 times square root of x is negative 9 square root of x. Negative 9 times 3 is negative 27. Take a moment to look at that multiplication. Make sure you understand how I got that. Are there any questions on that part? Can I cancel these two terms out? Yep, those are like terms. So I'm left with x minus 9 and all this stuff on the bottom. Well, guys, let's take a moment. I'm going to plug 9 in to see if I can do direct substitution. Let's do this. What's square root of 9? 3 times 9 is 27. Plus 3 times 9 is... So I'm going to write all these 27 down to keep track. So I got 27 or 27. What's square root of 27 here? Square root of 9. 3 times negative 9 is what? Negative 27. So does that cancel out one of those 27s on the bottom? And then I got another negative 27. So I'm still at 0 in the denominator. So I got to do something else. I did all that work. I still got 0 in the denominator. So I'm thinking, okay. To me, if I look on bottom here, don't some of these things have stuff in common? Could I not factor that? So here you're rationalizing and you're factoring. So here I'm going to take an x out. That leaves square root of x plus 3. Here I can take a negative 9 out. That leaves a square root of x plus 3. Do you see how I factored that? And now I'm going to have x minus 9 over x minus 9 and square root of x plus 3. Can I cancel anything out? These x minus 9s, can I? What does that leave on top? Now let me try direct substitution again. What is square root of 9? 3 plus 3 is? So your answer is 1/6. That's your limit as x approaches 9. It's going to the value of 1/6. Okay. Let's look at number 10. The limit as x goes to 3 of 1 over x minus 1 over 3 x minus 3. If I directly substitute 3 in here, 3 minus 3 is 0. Will that work? No, so I got to employ another strategy. Can I factor anything here, guys? No. Can I rationalize? Do I need to rationalize? No, there's no radical. So what do you see in the numerator? Subtracting fraction. I need to go to the side and find a common denominator. Watch this. What's your common denominator between x and 3? 3x. I'm going to put a 3x. I multiply that by 3, multiply the numerator. Multiply that by x, multiply the numerator. So I get 3 minus x over 3x. So I'm going to go back to my problem and put that in. 3 minus x over 3x over x minus 3. Well, that's a complicated fraction there, guys. So what I'm going to do is come to the side and write out what it means. It is saying this divided by this. Well, let's flip it. Change that division. That becomes 1 over x minus 3. This is multiplying. Now let's think about this thing right here. These look very similar, don't they? I want to ask you, can I cancel those out? You remember last year in algebra tree, the only time you can do that is when, if you got this thing and the other thing is total opposite. Do you see how the x is positive, x is negative here? That's a positive 3 and negative 3. Those are complete opposites, aren't they? If I cancel those out, then I got to put a what in there? Problem somewhere. A negative 1. Alright, so you will get, we're going to finish this tomorrow, okay? Remember, look at your homework. We did some of that, omit 16, and we'll continue this tomorrow. You're going to have a checkpoint tomorrow in graphing, looking at graphs and tables, okay? Have a great day. Scotty, what you got to get made up, okay? Have a good one, Josh. Yes, sir. It is page 9, 2 through 12 even. We did some of that today. In class, page 10, 13 to 18. Have a great day. Omit 16. Make sure you put your covers on my calculator. Do not just throw a calculator up there without a cover, because we won't be using them.